Day 4, we get this as puzzle input. It's supposed to represent a couple of scratch cards with winning numbers on the left side of the pipe and actual numbers on the right side of the pipe. Now for each card we're supposed to determine how many of the actual numbers are winning numbers. As far as I can tell, in this example input, all the actual numbers are unique for each card. And this was also true of my puzzle input, so I'm going to assume this going forward. And then if we find the number of actual numbers that are winning numbers, we're supposed to add them up, but not in a linear fashion, but sort of a exponential fashion. So if we get one match, we add 1. If we get 2 matches, we add 2. But if we get 3 matches, we add 4. And if we get 4 matches, we add 8. So it multiplies by 2. Okay, let's jump into the code. So first we're going to separate out the lines from one another. And then for each line, we're going to split it in half around the pipe symbol. And we're going to call the first half winning numbers, the second half actual numbers. But the winning numbers still contain the word card with the colon in the beginning, so we have to remove that part as well and see if it works. And it works. Now we're going to take the overlap, which is the intersection of the two sets of both number groups. Mind you, we have to still split each number group to get the actual numbers out of them. Then we print the overlap and we see it works. Although I think we can make it a bit clearer. We print out the length of the overlap so we see the number of matches. So it's 4, 2, 2, 1, exactly how it should be. Now we initialize a variable called points and we add the number of matches to it. But like I said, not in a linear fashion, but in an exponential fashion. And we get the right answer. Now, just for fun, let's try that same thing using the regular expression module, just to see how much simpler our code could be. So we're trying to match two different groups, two groups of numbers. One is after the colon, but before the pipe. The second one is after the pipe. For these groups, we use the dot and the star, because the dot will match anything, and the star says however much there is of anything, basically. Now if we use the findAll function from the regular expression module, we don't even have to split apart the lines beforehand because our regular expression is already adapted to matching lines. So as you see, it works and it's way prettier than what we had before, way simpler. Now if we just do the same thing we did before, look for the overlap, add to the points, we get the same result, just in a way more elegant fashion. Part 2 is different but similar. What we still do is we try to find all the matches for each card. Here we had 4 matches. And now for the next 4 cards, we add 1 card each. So now we start out having 1 instance of each card, and now we added another card 2, another card 3, another card 4, and another card 5. Now we move on to card 2. We found 2 matches here. So for the next 2 cards we have to add 1. But we don't just have to do this once, we have to do this twice because we have 2 instances of card 2. So we actually add 2 to card 3, 2 to card 4. Now we have 4 instances of card 3. So there's this accumulating effect happening. We had 1 to begin with, we added 1 through card 1, we added 2 to card 2, so that's a total of 4. We just continue this to the end, and we're assured that nothing strange would happen at the end. Like at card 5, we get 2 new cards, so we get card 6 and card 7, but there is no card 7. So errors of this kind are precluded by the way the puzzle input is structured, so we don't have to worry about that. So let's see how we do this in Python. So for this part, it actually does make sense to split the lines because we need to know how many cards there are. We need to know this because we're going to keep track of how many cards we have of each before we even reach that card. So in the beginning, we already need to know how many cards there are in total. We initialize our array called cards with 1 for each location because we have 1 card of each. Now we iterate the lines. We go through each line, And we basically do the same thing as before. We extract the winning numbers and the actual numbers using our regular expression. We can use find iter, we can use the search method. I just like to use find all. It's my favorite. Only problem with find all is it returns a list, and a list of all the matches inside of that line. Of course, it's a list of one element because there's only one match in each line, so it's kind of redundant. We have a list and a tuple inside of a list. We want to get to the tuple so we can unpack it. So what we do is we index by 0, and now we got rid of the list. We're left with the tuple. Now we can just simply unpack it. We can get the winning numbers and the actual numbers from that tuple. Let's see if this works. Oops. And it works. Now we get the overlap again by taking the intersection of the sets, and we also have to keep track of which card we're currently at, so we index it using enumerate. Because for the following indices, like I plus 1, I plus 2, up to I plus the number of matches in the current line, we have to add how many instances we have of the current card. So this is where this accumulating effect takes place. We access how many cards we have of the current card by looking in our cards array at index I, and we add that to all the following indices. In the end, we take the sum of our cards array, our cards list, because this sum embodies how many cards we looked at in total. We get the result, and it's 30, which is perfect. That was part 2. Thanks for watching. If you're also a big fan of Advent of Code and it's helping you to learn to program as it helped me, you might also enjoy visiting my website where I keep all the solutions I've got so far, presented in an interactive and hopefully appealing way, as well as other fun stuff. See you there.